Forget which AI model is the smartest. The question that decides what you can actually run at home is simpler than that. How much memory does your graphics card have? That one number picks your model for you. Say you choose a 20 gigabyte model and you try to run it on your potato PC. You already know the result it's going to choke. And the thing is, it's not even the model's fault. It's a machine problem. You're trying to squeeze the wrong model into the wrong PC. So in this video, I'm going to fix that for you. We're going tier by tier, 4 gigs, 6 gigs, 8 gigs, and past that, and for each one, I'll tell you exactly what runs, what doesn't, and what I actually tried that failed. But before we get into the models, there are 2 things you need to understand first, because you're not just going to run a model. A model is just a file sitting on your SSD. What actually matters is the software layer that loads those numbers and serves them to your editor. That's what determines your entire experience. Right now, the 2 most used runtimes among developers are Llama and LM Studio. Llama wraps the complex inference stuff into a dead simple command line. You do Llama pull model name and you're running. LM Studio gives you a GUI if you prefer clicking over typing. Both work fine. Pick one. Now the second thing, RAM and quantization. Models are trained in 16-bit precision. A 7 billion parameter model in 16-bit needs about 14 gigabytes of RAM just to load. Most machines can't do that, so quantization comes in. It compresses those weights into smaller formats, 8-bit, 4-bit integers. You'll see tags like Q4, KM, or Q8 on every model file you download. A 7B model that was demanding 14 gigs? Its Q4 version runs at around 4.5 gigs. That's the version you actually want on most machines. Now, quantization does come with a trade-off. As the size decreases, the model loses some of its quality too. So if you're on a potato PC, run a smaller model at Q8 rather than squeezing a bigger model down to Q2. A sharp small model will beat a lobotomized big one every time. Now let's get into the tiers. First tier, 4 gigs. And I'm going to be upfront with you here. You won't be running serious coding tasks or complex reasoning at this tier. But for summarization, simple Q&A, lightweight chat, explaining a function, writing a docstring models at 4 GB are genuinely usable. People with 4 GB cards act like local AI doesn't apply to them. That's wrong. Your main option here is Phi 4 Mini, a 3.8 billion parameter model by Microsoft. They trained it to be efficient, and it shows. It scores around 68% on MLU and 70% on human evil, which honestly is not bad at all for a 3.8B model. It handles basic code completion, explaining existing code, fixing small bugs. Don't expect it to write a complex multi-file application from scratch. It's a surgical tool, not a bulldozer. The other name that comes up is Gemma 4e2b, Google's 2B parameter model from the Gemma 4 family, released around April 2026. This one is better at text generation, summarization, analyzing documents, writing. Qwen 3.52b is better at coding. So depending on what you actually need, pick one or the other. Now what you should not do at 4 GB. Don't try to squeeze larger models onto it, because I did, and here's what I got. I tried running Mistral 7BQ3 on a 4 GB card. It ran, but at 4 to 5 tokens per second. The model kept spilling out of VRAM into RAM and choking on anything beyond a 1-line prompt, so keep that in mind. Second tier, 6 gigabytes. More interesting than people give it credit for. At this tier, you can carefully fit some 7 billion parameter models if you're careful with quantization and you don't go crazy with context length, because every extra token you add to your context window eats into the headroom you need for the model weights themselves. The safe bet here is Phi 4 Mini, same model from the 4 GB tier. On 6 GB, it's even more comfortable at Q5. You're looking at 15 to 30 tokens per second. This is the no-risk option. You pull it and it runs at good speed. If you just want something that works without thinking too much about it, start here. If you want to reach up, go with Mistral 7B at Q3km. Mistral shines at 6 GB specifically for writing commit messages, readme files, documentation, drafting emails. The outputs at this size are clean, and they follow instructions well. For that specific job, it's one of the better 6 GB picks. But keep in mind, you're fitting a full 7B model at a compressed quantization, so the quality loss going from Q4 down to Q3 is noticeable. Now, if you specifically want a coding model at 6 gigs, go with Qwen 2.57B at Q3KS. Same size range as Mistral, but Qwen's coding benchmark scores are meaningfully higher at equivalent sizes. I used it for a few weeks for boilerplate and basic Python scripts, and it was fine for that, but I'll tell you where it fell apart. I was trying to debug a Flask app with SQL Alchemy, and Qwen kept giving me suggestions for methods from an older version of SQL Alchemy. And after searching a lot, I found that it's a known failure mode for small models on code tasks. They hallucinate outdated APIs, and they don't know they're doing it, so keep that in mind. One more important thing at this tier: keep your context window at 8K max. Try to push to 32K and you'll overflow to RAM, or Llama will crash mid-session. I've had Llama die more than once because the KV cache grew bigger than expected. The fix is setting the context length explicitly when you pull the model. Don't let Llama pick a default. I'm mentioning this because it took me several failed sessions to figure it out. Third tier, 8 gigs. This is where local AI actually gets good. With 8 GB, you can load a proper 7 to 9 billion parameter model at Q4K meters quality, with a real context window at real speed. This is where the experience stops feeling like a compromise. My go-to pick here is Qwen 3.59B. After benchmarking 5 models on an RTX 3070, this is the answer for 8 GB by a significant margin. At Q4KM, it sits at 6.6 gigabytes in Llama. That leaves actual headroom for context. It's faster than older 8B models, scores higher on every benchmark I ran, and it's the only model I tested that stays fully in GPU memory, even at 32K context on 8 GB VRAM. On the Artificial Analysis Intelligence Index, it scores 32.4, 38% higher than the runner-up at this tier. It supports up to a 200K context window without major performance collapse. For daily coding, it's fast, accurate on functions and algorithms, and good at explaining its own output. Genuinely usable as a daily coding assistant if your codebase isn't massive. Second option at this tier is Llama 3.38B. The most balanced choice here, mLu of 73.0, Human Evil of 72.6 at Q4KM. The community around Llama is unmatched. There are fine tunes on Hugging Face for basically every niche. Legal code review, if you're doing something specific, there's probably a fine tune for it. The one downside I found that it uses a bit more RAM than Qwen 3.59B at comparable quality. Still fine at 8 GB, but tighter. And if you want pure speed, go with Mistral Small 37B. Highest tokens per second among 7 to 9B models on mid-range hardware. MT bench score of 8.0 follows instructions well, produces clean outputs. If latency is the thing that kills your focus more than anything else, this is your pick. Now for those of you past 8 gigs, 16 GB, and 24 GB, I can share personal experience here because I run an RX 9060 XT with 16 GB of VRAM. At 16 GB VRAM, you can comfortably run Qwen 3.627B at Q4KM. It fits with room left for a decent context window. Near commercial reasoning capability, fast enough to feel natural. If you're building out a machine specifically for local AI development and you want one GPU to handle serious work, 16 GB gets you there. For autocomplete alongside your 27B chat model, run Cadastral. Keep them separate 27B model in your sidebar. Cadastral feeding tab completion. Set max prompt tokens to 1024 for autocomplete. If you try to use the 27B model for autocomplete, your editor becomes slow enough to actually break your flow. If you have 24 GB VRAM like RTX 4090 or RTX 4080, Qwen 3.627B fits easily with plenty of headroom. You can also start testing 30B MoE models. The experience at this tier is genuinely close to a cloud coding assistant in most real-world scenarios. Not a marketing claim, just what it actually feels like day to day. And for those with a Mac Studio with 128 GB unified memory or a multi-GPU rig, you can load Qwen 3 Coder next. 80 billion parameters MoE, but it only activates about 3 billion per token. You need roughly 45 GB across RAM and GPU for the 4-bit version. In return, you get a 256K context window and 58.7% on SWE bench verified. Claude Sonnet 4.6 scores 62.4%. That gap is smaller than most people realize. That is the whole ladder. 5 brackets, 5 models, and every one of them ran on hardware you can sit on a desk. Now, the honest catch, because I'm not going to oversell it, none of these are GPT 5.6 or Claude Fable. The closed frontier still sits around 90 on these coding tests, and local still trails it. This is the best you can own, not the best that exists. So, how do you choose? Simplest rule I can give you. Find the biggest model that fits your memory with a little room left over for context, and run that one. When it fits, bigger still wins. It is almost that boring, but the real headline is not any single model on this list. It is that the one that fits your box today is dramatically better than the one that fit it 6 months ago. The floor is rising, and it is rising fast. And if you have never done this, do not overthink it. All the links are in the description. Go check them out, as you are about 10 minutes from a private model, not a weekend, because every model here is a free download on Hugging Face. Pull the one for your bracket, load it up tonight, and go find out what your own hardware can actually do. I really think it is going to surprise you. If this saved you a week of trial and error, subscribe. I break down the local AI stack here every week. I will see you on the next.